And we want to, let's see, and we also probably have a bunch of extra attributes coming in here that are going to cause us problems. Let's say that we delete them now. So after the unpack now, we're going to have things like shop material path in particular, but really just a lot of the stuff is in the way. We don't care. We might want to know the name of the primitive that it spawned from. Probably not. I think the rest would be more useful. So we could build a new rest here, but besides that, we don't really need the rest. So we don't need the rest. So we want to delete everything but velocity and density. Everything else, really on any of these other things, can go. And as we recall from before, by typing pop network, it will make a DOP network. Just plug it in. It'll have a bunch of stuff in there by default. Press play and we'll see something. So that's something. It doesn't look great, but it's a start. So what is it doing? It's scattering onto the surface of the first context geometry, which is good. So that's a start. What do we need to change? A bunch of things. One thing we're going to want to change is going to be we want to use the density as the emission attribute. So looks largely the same so far. I believe this is looking at the point attribute. Let me just make sure that density here is a point attribute. It is. Good. Okay, so we got that going. What else do we need to do? We're going to want to set the amount of particles that actually come out of it. We'll do this like scale by area, because there'll be different amounts of different sizes and surface areas of ridges coming in every frame. We're not going to know exactly how many particles we want. We can't set them here exactly. We needed to scale it by the reference area. You'll notice the lower you make this, the more there will be. So we're going to want a lot more. So let's do that. So there we go. So now now it's scaled by area, which is good. We're going to want to turn on that just born thing again. So just get another just born group here. We're going to want to jitter the birth time, not positive. I don't know why that's the default. It seems strange to me. We're going to want negative, meaning we want the particles to be spawned behind, like trailing the source geometry and not ahead of it. So make sure you put negative on. Cool. We're going to want to play with the attributes here. Maybe just give it a little bit, 0.1, 0.1, 0.1 variance so that it kind of spreads out a little bit. Maybe even a little bit more than that, like double it. Because we're going to want it to really come apart. This is not going to be a very like visible aspect of this, but this will be another nice subtle detail. Okay, so obviously it doesn't look very good right now. There's no gravity for one. So like before, we're going to want to drop a pop force down on here and say go down. Okay, so that's something. We're going to want to have, let's see what else we want to do here. Let's use a wrangler actually to offset where these things are spawning in space. And actually I'm going to turn the variance off for a minute, just so we can see. So they're like these long lines, basically. That's what we're getting right now. So let's give it a pop wrangle. And the pop wrangle is going to say, hey, were you just born, basically? We got that just born group. If you were just born, then we're going to come up with some scale that's equal to your unique ID, unique ID from 0 to 1, all the way. And whatever your starting velocity is, change it. Just literally scale it by that amount. So now when we run it, we get these cool streams. And that's one of the main secrets to getting cool streams, is there's no built-in thing on here. Like you can't do like an expression here to change the amount of inherited velocity. We have to do it per point. And that's what's so great about wrangles. So now immediately we've got something much more interesting to look at here. Cool. What else do we want? We're gonna want like a pop wind, just to give it some extra something. So our pop wind can be, we'll just keep this, the air resistance, the default. We can use the Vexpressions again to say, I'm going to change one of these parameters on here using an expression. In our case, we're going to want to say like the actual air resistance here, that should vary also. So actually, I don't remember what it's called. Air resist. So that was close. The air resistance will also be a random between 0 and 1. And what will be nice about this is it will account for the different sizes and shapes of these small bits of particulate. So some of them will sink to the ground slower than others. It'll break them up in a little weird ways. Yeah, it'll be nice. So we got that going on. What else do we want to do? Let's say, well, we actually haven't given it a ground plane to collide against yet, so let's do that. Ground plane, merge it. I'm not so concerned that these accurately collide with the scarring from before. In fact, I'm just going to say when you do collide, just stop. So, or even better, let's just say that it has a high friction, and so does this, and it has very little bounce. So let's see what that looks like. So they just rest on the ground, like you can see. Yeah, looking at this now, I'm not actually really loving the broken up air resistance on this thing, so I might turn this off. That is probably better, actually. So never mind to that. So going back into this, what else do we want? We can say, we can give this more substeps, actually. Something like, we can force it to have more minimum substeps, which will just basically say do that many substeps. That can be nice to help with sourcing particles, especially between frames, which is why we did that time blend thing from before. We didn't even really update how many particles we want to do. Right now it's doing the constant activation, which again is scaled by the reference area. I don't know, I mean, this is looking nice. Let's bring back actually the variation that we had from before, which is the 0.2s, because you know we would expect it to kind of come apart a little bit in the air. And let's give it some actual wind amount on the pop wind also here. And we can play around with that. I'm gonna say, let's start with 1, see what that looks like. And you know, and this will serve to break up some of the particles too. I just wanna see some like, let's do twice that maybe. I just wanna see some like weirdness going on. And that's just more what I want. I want to see these kind of like curls, and you know, it's as if there's wind from the explosion itself. So there we go. That's what I want to say. And then also that the patterns they leave on the ground are not the straight lines that we just had a moment ago. So that looks pretty good. So I'm going to save that. Come back out here. If we go back to the other particle sim, let's just copy all this stuff that it had. The cacher, the sizes, and the colors. We're gonna just use the same thing, basically wholesale. I'm gonna say this is particles trails LQ. Of course, it doesn't exist. And size-wise, we could play around with this. I'm gonna say let's just make it like 80% of the size or less. Just that this is not like particles coming from the ground. This is like small particles coming from small pieces. So I'm just going to say like, you know, and we could play with this in the interactive rendering mode, and you might want to for practice, but I'm just going to like, well, that's way too small. Just something like that. So this is 4 times as large as this one. The colors can be the same. So it looks like that. Looks like we're getting the ground plane here, so I got to come back here and say just the pops themselves. And we don't even really need an HQ for this because this is, again, just going to be kind of a low-res extra sim anyway. So we'll turn this back on, save that to disk. I may not even need to pause this. Looks like I will. Okay, so I'm going to pause this, and then we'll take a look at what that looks like. Alrighty, and there it is. Pretty cool. So it adds a whole bunch of extra stuff on the ground here. Yeah, what do we think? Looks all right. Not bad. We can see like the wind kind of moving some stuff around on the ground, though, after the fact. I don't know if that I want that necessarily. Now I need to go over to the... Let's go back to the pop solver and just say, let's just have it stop when it hits the ground. And we could do what we did in the other particle sim and have it not apply to the stuff on the ground, but I think it'll just be fine to have it stop when it hits the ground. Okay, so I'm gonna cache this out, and then we will move on to making a little light touch with the smoke. Okay, so there we have it. Not moving on the ground now. Also, I would be curious just to see what it looked like. So let's choose a frame like this where we should see some of these streaks. Let's go over to our friend, the Metro node here. Let's just look at that one. Let's see, particle trail sim. Well, that in the ground, I guess. What does that look like? It's probably fine, but we should make sure that before we move on, there's nothing crazy going on here. So yeah, as you can see, just a little bit of extra trails, something subtle that will mix in with everything else we've been doing. Okay, good enough for me. Press stop, and good to go.